So we're going to learn about reference angles. And one thing I want you to keep in the back of your mind is there's something else in this chapter called coterminal angles. And you can't get the two things confused. Coterminal angles are angles that have the same initial and terminal sides, like negative 90 and positive 270. Those are coterminal angles. Reference angles is something different, okay? It says the values of trigonometric functions like sine, cosine, tangent of angles greater than 90 or less than 0, so angles not in quadrant 1, can be determined from their corresponding acute angles called reference angles. Now, what does that mean? Let's write this down, reference angles. What that means is we want to do sine, cosine, tangent, or that are trig functions that are not in quadrant 1. We can use quadrant 1 angles to find them. The reference angles are quadrant 1 angles, and any angle that's not in quadrant 1 has a reference angle that's in quadrant 1. Except for ones that are on the axes. If they're on the axes, they don't have a reference angle. Okay, I wrote the definition of a reference angle. Let theta be an angle in standard position. So an angle that starts on the positive x-axis. It could spin around clockwise or counterclockwise. It could be positive or negative. Could land in any quadrant. Its reference angle is the acute angle theta prime, which I just write the angle down. I don't usually write the prime. Formed by the terminal side of theta and the horizontal axis. This means the x-axis. So that is actually the most important thing. When you're doing reference angles, it's the amount of turn. It's always positive towards the x-axis, the shortest path to the x-axis. And we'll do a bunch of examples. If an angle has a terminal side on the axes, so like 180 degrees, it does not have a reference angle. Okay, so it says find the reference angle for each angle. So 140 would land in quadrant 2. Okay, you could draw this and just make an angle that lands in quadrant 2. The reference angle is not necessarily clockwise or counterclockwise. It's just the distance. So I draw the arrow both ways. It's the distance towards the x-axis. So not towards the y-axis. So not this one, ever. The shortest path to the x-axis. How many degrees would that be? Yell it out. 40. So that's the reference angle for this, 40 degrees. And that's always between 0 and 90, or in radians, 0 to pi over 2. So negative 120, what quadrant does negative 120 land in? Third quadrant. And we want to know how far away that is from being all the way around. How far is that? 60 degrees. Okay. That's all you do for the reference angles. Now, that's just how to find the reference angles. Why we do reference angles, we'll get to. We're just practicing finding them. All right, 280, what quadrant is that in? Fourth. It's barely into the fourth. 270 is on the axis. So this is 10 degrees past that. So is the answer 10 degrees then? Do you see why somebody might say 10? Okay. You don't want the turn to the y-axis. You want the shortest turn to the x-axis. Oh, I wrote 10 degrees. It's not 10 degrees. What is the answer? 80 degrees. It's 80 degrees more to get to 360. Sometimes you're backtracking. Sometimes you're not, but it's the shortest path to the x-axis. Okay. Let's do these radian ones. So you have 3 pi over 4. Do you know what quadrant that's in? Second. It goes 1/4, 2/4, 3/4. 4/4 would be pi. And so how much turn is left over here? and do it. We're gonna do it in radians. So it'd be 45 degrees, but we're gonna do radians. So what is in radians? Pi over 4. Now here's why radians is easier, and listen to the whole thing I'm saying here. If you have a fraction in radians that you can't simplify, you agree 3/4 is simplified, right? Then that denominator is going to be this denominator. So if you have 3/4 or 7/4 or 11/4 or -9/4 or -13/4, they're all pi over 4. Okay? So if its denominator is 4, it's pi over 4. Now if it was 8 pi over 4, that can be simplified, or 6 pi over 4, that can be simplified. So those wouldn't be pi over 4. But if it's 101 pi over 4, the reference angle is pi over 4. So these are actually easier. I can just look at this and know it's pi over 6. I can't simplify it. It's got a 6 on the bottom. It's pi over 6. But I should do it. 11 pi over 6 brings you all the way almost to the end here. It brings you into quadrant 4. 12 over 6 would be all the way around. Is 11 pi over 6. So what's the amount of turn here? Pi over 6. Now, I know the answer on this one that we're about to do is going to be pi over 4, because I already explained it to you. But I want you to illustrate it, okay? Even though we know the answer to be pi over 4, do the illustration of this one. This one's illustration is slightly different. Maybe I should have done more like this one, but do you notice like this one, when I'm finding this distance, I don't keep going the same direction, where a lot of these I kind of went the same direction. I don't want this turn. I don't want this turn right here. I want the turn that's closest to the x-axis. So you want to go the shortest path to the x-axis. So this one, I'm not going backwards or forwards. I'm just finding this distance, but it might look to some people like I'm going backwards, and it's the only one that's like that. But that distance is pi over 4. And like I said, if it has a 4 in the bottom, it's pi over 4. So like if it was 17 pi over 4, it's pi over 4. -3 pi over 4, pi over 4. Everybody happy with that? Okay. Now you might say, what does this have to do with anything? Well, we're going to get there. We're going to find the value of trigonometric functions like these without having to have the full unit circle. And eventually you'll be able to do trig functions like this with, maybe doing it all in your head. Now, doing it in your head does not mean instantly knowing the answer, but, thinking of things that you know are true and then figuring it out. Some of these are going to be quicker than others, but we're going to draw quadrant 1. On the quiz that you're going to take next, I want you to draw quadrant 1. Okay? Eventually, you might be able to do these without drawing anything. But I think it's a good idea when you're doing your homework and your review and your quiz to draw quadrant 1. So we're going to draw quadrant 1. Now, when you draw these lines here, these are not equally spaced. If you draw them equally spaced, no one's going to know, but just so you are aware, they're not equally spaced. It's a 30-degree turn, then 15, then 15, then 30. It's not all equal. So I'm going to do degrees, I'm going to do radians, I'm going to do sine, cosine, and I'm going to do tangent. If you want to leave off the degrees or you want to leave off the tangents, you can, it's your unit circle when you do the quiz. So I'm going to put the degrees down. 0 degrees, 30 degrees, 45 degrees, 60 degrees, 90 degrees. And then I'm going to do radians. Like writing 0 radians, do you have to do that? Probably not. sometimes it confuses people that the denominators are getting smaller as the things are going up. Those are getting bigger, even though like a 2 is smaller than a 3. Hopefully that doesn't confuse anybody. But those radians are getting bigger as I go around this way. Pi over 2 is bigger than pi over 3, which is bigger than pi over 4, which is bigger than pi over 6. Okay. So you got to put this ordered pair down. If you do this ordered pair wrong, then you're probably going to do this ordered pair wrong, and you'll get every sine and cosine and tangent of 30 and 60 wrong. Okay, so without looking, is this 1/2 comma root 3 over 2, or is it root 3 over 2 comma 1/2? Okay. Root 3 over 2 comma 1/2. Now, I don't know how you memorized it. And, you know, if you want to do different kind of memorization techniques, you can. But remember, it's not really supposed to be that complicated. There's a triangle right here. This is the x value. It's the length of this side of the triangle. This is the y value. It's the length of this side of the triangle. The x is bigger than the y. I could see the x is bigger than the y. So the x number should be the bigger number, and root 3 over 2 is bigger than 1/2. And then this one is reversed. Oops. That's why I said if one of these is wrong, you're probably going to do the other one wrong. And then on this triangle, the x and y are equal in that triangle. The distance from the x for the x side of the triangle and the y side of the triangle are equal. So it makes sense that the x and y are equal. Most people know this one. And then if you want to label these two, I mean, it's up to you. This one is 1, 0, and this one here is 0, 1. You don't have to label these if you don't want to. Put as much information as you think you need. I'm going to do the tangents as well. I'll do them in purple. All right. Which is the easiest tangent value to figure out? 45 degrees. I don't think you have to memorize the tangent values. I think you can figure them out as needed. You just divide the sine by the cosine, sine over cosine. So this is usually the easiest one for people because it's same number, sine over cosine, y over x. You just do y divided by x. All right, what do you think is the next easiest one to do? Well, I'll give you a choice. You want to do pi over 3 or pi over 6? Which one do you think is easier? Pi over 3? I think that one's easier because it's this one over this one. The root 3 on the top is easier. This one's root 3. So you have a choice. Either you will figure it out on the test and write it down, or you will memorize it and just know that. I wouldn't memorize it. I'd figure it out. This one, I'll write the workout. Don't write this workout. Is sine over cosine. The 2's cancel. The root's got to go out of the bottom. And you end up with root 3 over 3. Okay? So, you know, you might have to do that work. Or you can, you know, memorize it a little bit and just say, you know, the one where the root's in the bottom ends up being root 3 over 3. All right, let's do these ones. What's tangent of 0 degrees or 0 radians? It's y over x, so it's 0 over 1. What's 0 over 1 equal to? 0. The other one is 1 over 0. What's that one going to be then? Undefined. Tangent can be undefined. Sine and cosine are never undefined. Okay. So, you will draw that on the quiz. That, you know, is that obviously shorter than drawing the entire unit circle. That I would draw. If you think you can get away with doing these problems without drawing that, you know, you could try. At some point you will be able to, whether it's, you know, today or Tuesday or the end of the chapter or next chapter or, you know, in calculus, but eventually you won't even need to draw that. Okay. Now, we still haven't said how you're going to do ones that are not in that quadrant, okay? Everybody agrees 7 pi over 6 is not in quadrant 1, right? We're not going to look at the unit circle. These are the steps to figure this out. It says use reference angles to find the values of the following, and these are the steps. So it says step 1, identify the quadrant the angle lies in. So you would need to know what quadrant 7 pi over 6 is in. What quadrant is 7 pi over 6? 3, okay? You can just go like this: 1/7, 2/7, or 1/6, 2/6, 3/6, 4/6, 5/6, 6/6 is pi, 7/6 is quadrant 3. Some people will know instantly it's quadrant 3. Some people will need to trace it out, but it's in quadrant 3. Is sign positive or negative in quadrant 3? Signs are y values. In quadrant 3, y values are negative, so it's negative. A lot of people memorize this all students take calculus memorization tool. Have you seen this before? All students take calculus? Okay, well, if you haven't, let me explain what this means. The acronym ASTC is all students take calculus. That's the way of remembering those letters. A means all of them are positive. S means only sign is positive, which is the y values. T means tangent is positive. And C means cosine is positive. Okay? So all of them are positive, sine's positive, tangent's positive, cosine's positive, otherwise they're negative. So in quadrant 3, only tangent's positive, so it means that sine's negative. Okay, then it says identify the reference angle. So the reference angle of 7 pi over 6 is pi over 6. It's the amount of turn towards the x-axis. 7 pi over 6 is pi over 6 away from the x-axis. That's what we're doing on the previous page. Then I look at my problem here. I wrote it out, and I look at sine, and I look what sine is. Sine is a half. Now, that's not the answer to the problem. Okay. Sine of pi over 6 is a half. So 7 pi over 6 has the same value, 1/2, but it's not positive, it's negative. And so I just make that negative and I'm done. So the value of 7 pi over 6 and pi over 6 is a half, but one of them is positive, one of them is negative. We'll do another one. Okay, so first thing I do is figure out what quadrant this is in. 5 pi over 3, what quadrant is that in? 4. Okay, is cosine positive or negative in quadrant 4? It's positive. Then I find the reference angle. The reference angle, again, for these radian ones, if you can't simplify this fraction and it has a 3 on the bottom, it's pi over 3. Okay, 7 pi over 3, 11 pi over 3, 13 pi over 3. Those are all reference angle pi over 3. So then I do cosine of pi over 3. Okay, I look at pi over 3, and I drew this out to do this, and that's a half. Eventually, that step you can do in your head. You'll say pi over 3, you'll imagine quadrant 1, and you'll say a half. And then since this one is positive, that's the answer. Try 3 on your own. Is there any questions about this while people are working? So 7 pi over 4 turns into quadrant 4, and it's negative, so you should have started with that. The reference angle is pi over 4. Now, what you want to write here is up to you, but the correct thing to write is root 2 over 2, because sine of pi over 4 is root 2 over 2, but that's not our answer. The answer to our problem is negative root 2 over 2. That's what sine of 7 pi over 4 is equal to. It's negative because it's in quadrant 4. So I can figure out what sine pi over 4 is, and I just need to know that it's the same number but negative. Is that what you had? Okay. This one's a tangent one. It makes it a little more challenging. We have 5 pi over 3. I'm going to do this wrong on purpose. Watch me count 5 pi over 3. 1/3, 2/3, 3/3, 4/3, 5/3. Boom, quadrant 3. Do you know why that's wrong? 1, 2, 3, 4, 5. I know how to count. When people count thirds, they have to remember not to land on the y-axis. 1/3, 2/3, 3/3. You do land on the x-axis. 4/3, 5/3. Do you see why people would do that wrong? You don't land right here when you count thirds. When you count fourths and sixths, you do land there. But when you're counting thirds, you got to skip that. When you count that, go like this: 1/3, 2/3, 3/3, and check to make sure that's equal to 1 pi. 4/3, 5/3, and then check if I do one more, that's 6/3, which is 2 pi. So it's in quadrant 4. So quadrant 4, I don't know why I'm writing the word quadrant, but quadrant 4, tangent's negative in quadrant 4, it's positive in quadrant 3. So I want to figure out the tangent of pi over 3 and then make it negative. So if you don't have these tangent values written down, then you just got to figure them out. And if you do have it written down, then you just know, okay, tangent of pi over 3 is root 3, so my answer is negative root 3. All right, cosine of pi over 6 is in quadrant number 4. It's just a slight turn into quadrant 4. In quadrant 4, cosine is positive because cosine is x values, and x values are positive in quadrant 4. If you think about negative pi over 6 and positive pi over 6, their x value is the same. So the coterminal angle is pi over 6. Right? The amount of turn for negative pi over 6 is pi over 6 away from the x-axis. What we're going to talk about later is that cosine is an even function. In an even function, opposite inputs give me opposite outputs. Give me the same output. It's even. Opposite inputs give me the same output. So if you have a negative cosine value, you could literally just get rid of that negative, and it's equal to cosine of pi over 6. So cosine of pi over 6 is root 3 over 2. So in fact, for negative cosine values, I could just make this a plus. I'll tell you about that more later, but it's root 3 over 2. Everybody happy with that one? Okay. 5 pi over 4 is in quadrant 3. Is tangent positive or negative in quadrant 3? Positive. And the reference angle is pi over 4. Tangent of pi over 4 is 1. I have that written down up there. That's should be the easiest tangent value. If you don't know that automatically, you will eventually. Tangent of pi over 4 is 1. Is the easiest tangent value. And it's positive, so it's also 1. Here, it's positive root 2 over 2. Here, it's, positive root 2 over 2, comma, positive root 2 over 2. Here, it's negative root 2 over 2, comma, negative root 2 over 2, which, when you divide, gives you 1. All right. So, I know I got a lot of these, but we're just going to do these last 3, and then we're done. This one's a little bit harder because it's secant. So, first I got to figure out the quadrant. I got to go negative, and it's quadrant 3. Then I got to figure out the coterminal, or to me, not the coterminal, definitely not coterminal, the reference angle. The reference angle is pi over 6. But I would do cosine of pi over 6 and then make it negative because I don't have secant up there, so I do cosine of pi over 6. The cosine of pi over 6 is root 3 over 2. I think I do two things to that. I got to make it negative and I got to flip it. Okay? So the secant of, I can write pi over 6, I guess, but I'm just going to do, this is the answer, is this one flipped. Okay? And negative. So it's this one flipped and negative. Is this the answer then? Negative 2 over root 3? No, you got to get the radical out of the bottom. So it's the right answer, just not allowed to leave a radical in the denominator. Called rationalizing the denominator. Okay, do 8 and 9 on your own. So I'm not going to do the full problems. I'm just going to write the quadrants. Oops. And the signs. Some people had the wrong sign on number 8 when I was looking around. So both of these involve doing a reciprocal. So I found the coterminal angles. Reference angles, not coterminal. Reference angles. And then I would do the function that I know for my quadrant 1, and then I'm going to flip it later. So tangent of pi over 4 is 1, which means that the tangent of 3 pi over 4 is negative 1, and then I would flip it. So I don't know what you want to write down. Well, maybe I should write this down. So this might be much more than you would write, because I want you to write as least amount as possible. There should be some writing, I think. Do you need to write all this? No, but this is what I did. I figured out it's quadrant 2. I figured out it's negative. I figured out the reference angle is pi over 4, tangent's 1. I made it negative because it's in quadrant 2, and then I did reciprocal. You can't even tell that I did reciprocal here because reciprocal of negative 1 is negative 1. Okay, this one. I am going to do the sine of pi over 6, which is a half. It's a quadrant 1 value, so it's positive, and so the sine of 5 pi over 6 is also 1/2. And so the cosecant of 5 pi over 6 is just 2. Did you have 2?